Hello friends, I am Chandan. Today's topic is steady flow energy equation. This is my handwritten notes useful for GATE, SC, SSC JE, ISRO, DRDO, BARC and other competitive exam. You can download it from the description link and there is a telegram link. You can join to get notification from this telegram group. Okay, let's try to understand what is steady flow energy equation. So steady flow energy equation means a flow is said to be a steady flow when there should not be any accumulation of mass or energy inside the control volume. So if any system, if there is no accumulation of mass and energy, there is no accumulation of mass or energy inside the control volume, no accumulation of mass or energy inside the control volume, then it is known as steady flow or steady flow. So there if the flow is steady flow, there must be two conditions must be satisfied. What is this two condition? That is conservation of mass, that is initial mass flow rate mi dot, that is initial mass flow rate, and me dot, that is exit mass flow rate. So the initial mass flow rate must be equal to the exit mass flow rate. Now the second condition is that there must be conservation of energy. There must be conservation of energy. That means initial energy rate, that is equal to exit energy rate. Ei is the initial energy rate and ee dot, that means it is a exit energy rate. Now consider, so here mi dot, that is initial entering mass flow rate, and me dot, so here there is a dot uh, here, that is me dot, that is exit mass flow rate. Now consider here this is our system. Here this is our system. You can say that it is a control volume, and here this is an open system, and here this is the mass is entry to the system, and here the mass is exit from the system, and this is our control volume. This is our control volume, and here this is the boundary. Here this is the boundary. From this boundary, the heat is into the control volume, that is it is going into the control volume. It is going into the control volume, and we got some work from the control volume. Okay, we got some work from the control volume. Now just focus on if you see the initial inlet. If you see the inlet of this control volume, here this is the inlet. So in this inlet, the initial inlet mass flow rate, that is mi, initial velocity of the fluid, that is ci, initial pressure of the fluid, that is pi, initial or internal inlet specific internal energy, that is ui, inlet specific internal energy, that is ui, and inlet specific enthalpy, that is hi. Okay, so I is the inlet, you can see that, and e is the exit. Now here this is the reference point. Here this is the reference, and from this reference to this distance, reference to inlet distance, that is zi, and reference to exit distance, that is known as ze. Okay, now here if you focus on the exit section, the exit mass flow rate. So here there is a exit mass flow rate, that is me dot, exit velocity, that is equal to, that is ce, exit pressure, that is pe, exit internal energy ue, exit enthalpy he. Now you know that if flow is said to be steady flow if there is a mass conservation is there, and there is energy conservation is there. Okay, now if mass conservation means initial mass flow rate, that is equal to exit mass flow rate, and consider that is equal to m dot. Okay, that consider that it is a m dot. Now initial energy initial inlet energy rate, that is equal to exit energy rate. And E is basically, we know that E means energy is equal to kinetic energy, potential energy plus internal energy. So E is basically kinetic energy plus potential energy, kinetic energy plus potential energy plus internal energy. Now, in this equation here, initial internal energy, if the flow is steady flow, that means initial energy rate, that is equal to exit inlet energy rate, that is equal to exit energy rate. So energy, that means there is a kinetic energy, so that is why there is a kinetic energy half of m dot ci square. So okay, so m dot, because initial inlet mass flow rate, that is mi, you can see that this is m dot. So that is why half m dot ci square, half m dot ci square. And what is the potential energy? That is m dot g zi, m dot g zi. And what is the internal energy? That is m dot ui. And if you see the control volume, the heat is into the control volume, control volume. So from here you can see that plus of q dot. Okay, so that is equal to exit. In exit, the exit kinetic energy, that is half of m dot c square, exit potential energy m dot g ze plus exit internal energy m dot ue. And you find that there is some work which is produced, that is considered this is w net. W net is the work done to the control volume, net work done to the control volume from this control volume. Okay, now from here you can see that here in both side the mass flow rate, that is cancel out. So here in both side the mass flow rate, here both side the mass flow rate m dot m dot m dot. And here this q dot is converted to small q, and here m dot is converted, so cancel, and both side also cancel. And here w is converted to small w. Okay, so so from here okay, now this here, this small w, this is small w, that is equal to w of control volume minus p pi vi plus pe small ve. Okay, so why it is that? So you see that here, that is wcv is the control volume work, by the control volume work. And here when the initial mass is entering into the system, into the control volume, there is a negative work. Okay, so that is why there is a negative sign. So here that is why there is a negative sign here. This is a negative sign, and this is a positive sign, because work done by the control volume. So that is why there is a positive sign here, there is a positive sign, and work done on the system, so that is why that is a negative sign. So if you want to calculate small w net, that is equals to small cv minus pi small vi plus pe small ve, and just put the value in w small w net. This, just put the value in this side. Okay, so if you put this value in this side, you can get this data, this equation ci square by 2, plus if you rearrange this, you can get ui plus pi vi, because pi vi here going to left side. So that is why ui plus pi vi, and there is zi plus q, that is equal to c square by 2 plus ue plus pev plus gze plus w of control volume. So basically here ui pi vi, this is ui pi vi, this is basically ui plus pi vi, this is basically enthalpy, specific enthalpy. Okay, so you can write this into as a specific enthalpy ui plus pi vi, that is equal to hi plus ci square by 2 plus gzi plus q, that is equal to he plus ce square by 2 plus gz2 plus w of control volume. So this equation, this is the steady flow energy equation. This is very important. Just remember this data. This is very very important. Remember this data, this formula that is very very important. Hi plus ci square by 2 plus gzy plus q that is equal to he plus c square by 2 plus gz2 ze plus w of control volume. So this is basically first law of thermodynamics for open system. First law of thermodynamics for open system. So remember this data. This is very very important. This is a steady flow energy equation. So here Aj is the Aj is what? Aj is the Aj is the uh, specific inlet enthalpy. Inlet specific enthalpy, and there is a ci mean inlet velocity, and zi is the distance between the reference to inlet, and q is the heat transfer, and exit he is the exit specific enthalpy, and c means exit velocity at the exit velocity, and gd what is that is the difference between reference to the to the exit, and work done by the control volume, WCB, that is work done by the control volume. So this is the steady flow energy equation. Just very very important, you can remember this formula. Now now here the only assumption here, there is only assumption is steady flow. Okay, and you can apply this and this equation in steady flow devices like turbine, compressor, pump, nozzle, diffuser, boiler, condenser, and turbines. So apply this. You have to apply this equation. So this steady flow energy equation in that devices. So in next lecture we'll do that. So this is my handwritten notes. You can download it from the description. There is a Telegram link. You can join on this Telegram link, and like, share, subscribe my YouTube channel. And if you have any problem regarding any notes or anything, you can email me or you can message me. Okay, thank you everyone.